Hello. Hi guys, good morning. Welcome back to a new video. Ki halchal? Actually, it's morning. It's 1:13 a.m. So it's morning. Cool. So this is problem number 3. Problem number 4, we had a bit blunder. A bit of audio was missing. But yeah, the video is already live with the part 2, so you can just go and watch it. As you can simply see before even reading the problem itself, I can spot return prime number. So I expect that you must have watched prime crash course. If not, then go and watch it. It's pretty concise, short and crisp. Now, this problem simply mentions that you are given two integers n and m that consist of same number of digits. As you can see, n and m digits will be same. It has two digits. This also has two digits. So number of digits will be same. I can perform, again, you can perform following operations any number of times. The operation is choose any digit from n. Again, I can choose only n, but choose a digit that is not a 9 and increase by 1. So I can choose both the digits here. I can choose 1 or 0, because if I choose a 1, I will make it as a 2 0. If I choose a 0, I can make it as a 1 1. That's possible. Again, the only thing which they are referring is not possible is what if I have a number 1 9? I cannot increase this 9 by plus 1, because if I do it, it will become a 20. And maybe in worst case, what if it is 99? If I do a plus 1, it becomes 100. So this kind of thing would not be possible because they don't want you to increase the number of digits. Same way, they also don't want that if you have a number 0, you decrease it by 1. Now, before I go on further and explain you what to do, I'll quickly finish this and I'll solve your one very basic doubt which most of people had while solving the contest, which was that are they not considering leading zeros? If yes, then will it not give a better answer? So that's a question. But before that, just get the maksat out. Maksat is to actually get conversion from n to m by doing this transformation, or I can say the operation, such that any of the intermediate operation or even n or m should not be a prime number, So I can never convert my this 10 to 11 because 11 is a prime number. In this case, 4 and 8, obviously I have two possibilities. I can either increase or decrease. Any which ways, if I decrease, I might never reach 8. If I increase, I reached a 5, which is a prime number, so also it is not possible. Same way for 6. If I increase, it will become 7. If I decrease, it will become 5. Any which way, it is becoming a prime number, which is not. Answer is -1. Answer is -1 because I'm not able to reach. And they're also mentioning, make sure they also mention that even if n or m, as you can see, the answer is nothing but the summation of all the intermediate values along with the source and target value. So source is 10 plus 20 plus 21 plus 22 plus 12, which is the destination. The summation is that. And any of these values, which means 10, 20, which means including source and destination, any values cannot be a prime number. Now, before I go on further, the very basic stuff which many people had doubt on is that why can't you convert and make this as a 0 0, which means, again, obviously I increased this specific digit, it became a 2 0. I increased it, it became a 1 1, which means I increased this specific digit, it became a 1. I increased this specific digit, it became a 2. If I decrease, I obviously cannot decrease a 0, but I can decrease a 1. Yeah, that makes sense. And it is also mentioned that you can decrease as 1. But if you decrease a 1, this will become a 0. That 0 is actually nothing but a 0. The operation you were allowed to do is choose any digit from n and do this operation. So if I do and reduce it to 0, now the integer has become a 0. The operation which you can now apply on it is increase or decrease. Obviously, you cannot decrease from 0, you can only increase. So it became a 1. It is not a 0 1. It is a 1 only if you decrease it. And if you decrease it once, it became a single digit. which means that no matter how much you again, obviously if you increase to 2, it will become prime number, so you have to exit it. But even in worst case, if you are even able to reach 9, you cannot go and make it another 2 digit next, because you can never increase from 9. That is the reason you can never have corresponding leading zeros. I hope you got it, because if I can never increase the number of digits, which means I will never be able to even reach my value of m. Cool. Now let's come on and see that what you will do. Obviously, you will first look at the constraints. Constraints are n and m 1e4, which means that 1e4, I can have at max 5 digits in my number. Obviously, the very big and the very straightforward thing is that same number of digits are there, which means I have to try for all the possibilities. Why not? Let's try for all the possibilities. For a number 10, I will try for all the possibilities, which means, okay, first possibility is increase, next possibility is decrease, but make sure that you try increase and decrease on every digit. So I will try increase. Okay, on first digit, it will become a 2 0. Increase on second digit, it will become a 1 1. Okay, decrease on the first digit, it will become a 0 0, which is ultimately a 0. Decrease on the second digit, oh, not possible. Now, okay, this is again, so far, again, I have to try for all the possibilities. I'm just trying it. I will realize this is a prime number, so this cannot go further. Okay, now let's go and try. Obviously, decrease and then increase. You see, I'm just simply trying by myself. If I increase it, it will become a 3 0. If I increase it, it will become a 2 1. Okay, if I decrease it, it will be a 1 0. If I decrease it, obviously I cannot decrease the digit 0. Now, 1 0 was already visited, was already there, right? So there is no point of visiting it again, because I already visited it. Now you might say, Aryan, how would I know? Should I keep track of the visited array? Maybe you can, but you will see the more we go towards how we will approach this problem, you will see that automatically it will be handled. But yeah, you can handle it by using a visited array also. Now, obviously, if you try to increase it here, oh yeah, again, you can increase it, you can decrease it. Obviously, you will try to decrease, you will try to increase. If you try to decrease, not possible, try to increase, you will become a 1. Obviously, you will try for further process. Further process says that try to decrease and increase, which means, okay, I will try to decrease my 3 0. So, sorry, decrease my 3 0, it will become a 2 0. And again, I cannot decrease a 0. And again, obviously 2 0 is already there, so you can maintain a visited. Same way, I will try to increase my 3 0, it will become a 4 0 and a 3 1. And again, the same I will do it, decrease and increase. If I do a decrease, it will be a 1 1 and a 2 0. If I do an increase, it will be a 3 1 and a 2 2. Now, obviously, here also I might do a decrease and an increase. If I do a decrease here, it will be a 0 0 and then no decrease on the 0 end. But if I do increase, it will be a 2 0 and a 1 1. Cool. Again, here also I can only do a decrease, and if I do increase, okay, if I do a decrease, it will be a 0. If I do increase, it will be a 2. 2 is a prime number, so simply you have to stop here. Now again, I will not go and build the entire tree, but you get the essence. Let's simply go and build what will come from here. If I go and bring it up from here itself, you will simply see on doing a decrease. On the first, it will be a 1 2 1 2, and then on the next it will be a 2 1. It is a decrease. On the increase, it will be a 3 2 and then a 2 3. So you have seen that you reached your final destination, which is 12, and that's your corresponding answer. But again, for you, the maqsad was to get the minimum cost. The cost itself for you is actually the values. So as you can simply see, this is nothing but actually the graph or the possibilities which you end up trying. Because what you're doing here ultimately is that for each input, again for the input n, considering I can have at max 5 digits, I will try for every digit. Again, these represents decrease or increase, but for increase I can have at max 5 options to decrease, because I can have at max 5 digits. right? So I simply, again, it should not be 5, it should actually be 4 because it is less than 1e4. So it will be 9 and 9 and 9 and 9, which is 4 digits. So I ultimately realize I can have at max 4 digits, which I will be trying for. So I can have 4 options here, 4 options here, 4 on decrease, 4 on increase. That's it. Ultimately 8 options on every number n. Now the question will be, Aryan, okay, it seems like, okay, I'm trying for and building corresponding nodes, different nodes, and trying to reach my corresponding target. Obviously, I can reach this target by multiple other paths. Which path to choose? Which is the best possible path for me? For me, the best possible path is having the minimum cost. What is the cost of a path? The cost of path is, okay, for this specific path, the cost is obviously 10 plus 0. The cost is, again, obviously you can start off by saying, okay, for this node the cost is 10. As you go on to this path, the cost will be existing cost plus 0, so it will be 10 plus 0. For this, again, existing cost was 10, you go on to this path to 20, you will get a cost of 10 plus 20, which is 30. Then obviously to go to this path 11, you have the cost of 10 plus 11, which is 21. So you know, okay, now you have a node in the graph, you have the corresponding edge which has the corresponding cost. Ultimately, you have to get the minimum cost. Does it ring any bell? If yes, then it should have ringed you simply Dijkstras, which gives you the, okay, from any source to destination, if you want to find a path or if you want to get the minimum distance or minimum cost, when the edges are weighted, then you use Dijkstras. If the edges would not have been weighted, then you use a simple BFS. So I realized, okay, I will have to use the Dijkstras. Then and again, it is very simple now, straightforward, that for each input n, imagine n number n as a string, which means my n will be as a string. Again, make sure I'm imagining it as a string. The question itself is handling on digits. Thus, make sure that you convert each number back to the digit, or I should say the number itself, because this is what I have imagined so as to handle the changes in individual index of +1 and -1 easily. Cool. So again, let's take a better number, which is, let's say 46, or let's say 46. Okay. So I will simply do, okay, I will simply iterate on each index. At every index, I will simply increase it. I will make a 56. I will decrease it. I will make a 36. I will increase the next index. I will make it as a 47, decrease it 45, and so on and so forth for all the other indexes, which means here I will have 467, here I will have 469, and so on and so forth. I will try for every index and changing that to a +1, which means one higher or one lower. Now you might ask, Aryan, with that thing, obviously you mentioned that you can maintain something called as visited. Okay, but I mentioned that, okay, there's also a workaround that you would not be needing visited. That workaround itself says, because you are maintaining a Dijkstras, you know, for node 10, the minimum cost or minimum distance is 10. Again, minimum distance is for every node you maintain to reach to that specific node. This is a corresponding minimum distance or minimum cost. When you will go on to 10 again, from this 20, existing cost is 30. You go on to 10, the cost will tend to become 30 plus 10, which is 40. Already I have a minimum cost of 10. Why the hell I will actually go via this route and take a cost of 40 to reach a 10? I will never. So with this, it will help me to not visit the same thing again by simply maintaining a distance array. Obviously, I will have to maintain because I am using a Dijkstras, but this can help me to not keep track of visited. Although you can do it, but yeah, that's a simple optimization which we can have. The entire fact which can come to your mind is, what is the time complexity for this? Because it might feel like, if you had worked with numbers, it might feel like that it might actually expand pretty much very large, but it will not, because you will simply see that I can only expand considering I have my n. Considering the worst case, I have my n as 9999. This is the worst case of n. In that case, I will tend to expand my entire tree and go on to all possible values. Exactly once, obviously, exactly once you will go. Even if you go twice, you will stop there. So you realize, okay, on every node, which is obviously less than n, Aryan, why not more than this number n? Because if you go more than n, then you will go beyond the limit of m. Because m itself, you have to match m. You have to match m. Now you might say, Aryan, I will increase it and then decrease back. Okay, if you increase it, you will make the digits obviously as 5, which is not possible. And that is the reason they have mentioned that you can never increase the corresponding number of digits. So you can only roam around in the 4-digit number. You can only roam around in the 4-digit number. So you will roam around from 1 1 1 1 1. Sorry, I should say 1 0 0 0 0 0. Sorry, 1 1 2 3 4. Yeah, you will roam around from here up till 9999. That is the maximum roam around you can do, which means the maximum number of digits or maximum number of numbers which you can try for. And obviously on each number try, you go on to 8 possible options, which means at max, again, I'm only referring at max, 4 decrease, 4 increase. That's it. So considering the worst case, which is let's say 1e5 numbers I can go to, every number at max going 8, let's round off 10. So this will be the corresponding time complexity, or I should say number of visits in the worst possible case. Obviously I'm using Dijkstras, so it will be a log factor also attached to it. And that is actually your time complexity. Code, let's say the code, it's exactly very simple. Firstly, as I mentioned, you have to find out if things are prime or not, because you have to not go on to those numbers which are prime. So one way is to compute the prime, but obviously we have seen the corresponding crash course. So we know that we can simply use the Sieve template which we have given the crash course, and thus I have simply used the same template of Sieve, prime Sieve, and did a pre-computation for all the numbers which are prime. Then I will start off my actual function. I will firstly call my pre-compute primes. I will check if any of my number n or m is a prime, then simply return a -1, because obviously in that case I am screwed up. If my n and m already are same, so the cost will be n itself. As I mentioned, to reach from 12 to 12, you will have to go to 12 itself, right? That is the reason my cost will be n. Now I will maintain a distance array. This is simply for my priority queue, which is my Dijkstras. Then I will simply fill this distance array with the maximum value. I will take a long max because I am adding up the corresponding cost. Then I will take this length. This length will define me what is the length of my n or m. You can take any of them, both have the same length. Then ultimately initializing that for the distance of n. Again, distance is nothing but the cost here. In Dijkstras term, we use distance, but it is cost. For n itself, in the very beginning, I showed you the cost is the number itself. For if I go back to diagram, for 10, the cost is 10. The moment I go into 0, the cost will be existing cost plus the current number, which is 0. New cost for 0 will be 10. New cost for 20 will be 10 existing cost plus my value, which is 20, value 30. For this 30, the cost will be 30 plus 30, which is 60. For this 21, the cost will be 30 plus 21, which is nothing but 51. This is how we'll compute the corresponding cost. So again, I will go on. If I go back, yeah, I'll go on and I will make a priority queue. Priority queue simply nothing but a min heap. I will simply take a corresponding min heap, so that this min heap is minimum on the basis of cost, because obviously I want minimum cost path to reach my destination. So I am having this priority queue on the basis of min heap. Then I will simply push the starting node and the starting cost. Until my priority queue is empty, I will grab out the first element from the priority queue. I will get the corresponding node and the corresponding cost. Then I will check first that if the cost is more than the distance, which I already have, right, then there is no point altogether to go on to this node again, because I already have had a smaller cost, which means that if you remember, even if you have pushed this number 10 into your priority queue, but the cost for number 10 which you have pushed up would be 40. Already you see that you have a cost of 10, so there's no point of trying for a values from here. You will never try it. So you have to filter it out, and that filter is happening here. That if the existing cost itself is less, don't go. Don't try to do the extras here. If not, then make sure to try for all the neighbors. Before we go on to the neighbors code, there is also a case that, okay, if you have reached the end, which means you have to reach your destination, which is the M, simply return the corresponding cost which you have accumulated so far. Then you will go on to and find the neighbors. As I mentioned, the neighbors will be increase every digit, decrease every digit. These are all your neighbors. For every neighbor, get me the cost. What is the cost? Existing cost which I have plus my neighbor value is my new cost for my neighbor. I will check. Also, I will have a check that if the new cost is less than existing distance of neighbor, only then I should actually push this in my priority queue. Again, separate check here also. If yes, then I will make sure I'll push it in my priority queue with the neighbor and the new cost of the neighbor and also updating his corresponding distance. This will always be updated when I will have minimum distance. Now coming on to the neighbors code, this is simply nothing but for every, I will firstly convert this current number to the string value. I'll go on to all the digits. For every digit, I will try to increase it. I will try to decrease it. To increase it, I will check if it is more, it should be less than 9. If it is less than 9, only then I will be increasing it. I will get the corresponding digit. I will increase by 1. I will convert it back to integer value. Then I will check if it is not prime. Only then say this is the neighbor for this current node. And again, I will try to go and decrease it also and push it as a neighbor. This will be my possible neighbors. As I told you, in worst case, I can have 8 possible neighbors. 4 for decrease, 4 for increase. Again, considering 4 is the maximum length of my S. Thus, this is the corresponding code which will give us the corresponding answer. As I mentioned, the prime thing here will be my n log n for Dijkstras, but make sure this n here is nothing but this specific numbers n which I have 1e4. But as I mentioned that if you do even a 1e4 for each path of, or I should say for each option of Dijkstras could give you at max 8 options. So it will be nothing but your 1e4 into 8, which will again constant factor, so you can simply ignore it. But in ultimately your entire complexity will actually be handled by Dijkstras itself. And this is your corresponding time. Obviously, because you are having priority queue, so you can have at max n nodes. Thus, it will be O of n space for it. Cool. I hope you guys got it. If yes, please do smash the like button. Again, if you liked it, again, only and only if you liked it. And if you want us to continue further, because this act as a motivation. Again, I'm telling in the end because I don't want to waste your time in the very beginning. So yeah, bye bye. Take care. See you. Goodbye.